In the last lecture, we discussed the difference between the isolated and the non-isolated system, and we had the example of two people sitting in the room and how much money they have. If there's no doors or windows for that room, then the total amount of money is the same, while if you have a door or a window, the amount of money could be less or more depending if there's anybody who's an outsider who gave that money to the people in the room. And we discussed a little bit about an example of a pendulum, and we said the pendulum is considered an isolated system. Why is that? Because when you're having a pendulum that's hanging through a rope, when the pendulum is at the top point on the right, he will have the maximum potential energy and the minimum kinetic energy. Why is that? Because it will be the highest from the floor. That means it is getting, with a constant mass, a higher pull from the gravitational force. And as you know by your experience, the pendulum, when it's on the top point, it will have almost zero velocity, ready to go back to the other direction. So the kinetic energy is the lowest. So if you want to calculate the mechanical energy, in this case, it would be the potential energy plus the kinetic energy. Kinetic energy is zero when the potential energy at it is max. So EP max would be the EK minimum, and you can say EP maximum value would be EK0. And when the pendulum in this point, you have the minimum potential energy but the maximum kinetic energy. The pendulum would have the maximum speed, the maximum kinetic energy passing through this point, and over here will be the same as over here. It will have the maximum potential energy and the minimum kinetic energy. So the E mechanical over here, or the mechanical energy, would be the potential energy 0 plus the E kinetic. So at EP minimum, where the height equals 0. Now, if you want to draw a graph between the position in meters and the energy in joules, you can see here the kinetic energy will go from 0 all the way to the maximum value, then goes back to 0 for the pendulum, and potential energy would be at the highest at the starting point when the pendulum was swinging, let's say right or left. Then it will go to 0 when the pendulum is at the lowest point near to the floor, and it will go to the maximum potential energy as it is moving to A+. For the mechanical energy here is the same, so we can say the pendulum is isolated system and the mechanical energy for the pendulum is conserved, assuming there is no friction energy being introduced into the system. Let's take an example. You have an ideal pendulum. That means the pendulum doesn't have any friction or losses in energy in it, and it is an isolated system. So it is suspended by a string that is 2 meters long and pulled sideways and released. So somebody pull it to the side and release it so that it can gain its normal kinetic versus potential energy. At the highest point of the swing, the pendulum bob is 25 centimeters above the floor. At the lowest point of the swing, the pendulum bob is 5 centimeters above the floor. The mass of the pendulum bob is 250 grams. What is the mechanical energy of the pendulum relative to the floor when the bob is at its highest point? So at the highest point, the speed of the pendulum would be 0, as you know. The mechanical energy at that point equal to the gravitational potential energy. So E mechanical 1 would equal E potential 1 plus E kinetic 1. E mechanical 1 would be, translating this into parameters, that would be mass by gravitational acceleration by h1, plus the EK1 would be 1 over 2 mass by v1 squared. That would be 0.25 by 9.81 by 0.25 plus 1 over 2 by 0.25 by 0. And the mechanical energy at position 1 would be 0.613 joules. Asking as well, what is the mechanical energy of the pendulum relative to the floor when the bob is at the lowest point? So when the pendulum was at the lowest point, we know that potential energy was 0 at that point. And we have isolated system, so the mechanical energy is constant. So by the law of conservation of energy, the mechanical energy at the lowest point is equal to the mechanical energy at the highest point. So E mechanical at point 1 equals E mechanical at point 2. In this case, E mechanical at point 2 would be 0.613 joules. What is the kinetic energy of the bob when it is at its lowest point? The kinetic energy at the lowest point is the difference between the mechanical and gravitational potential energy at that point. So EM2 would equal EP2 plus EK2. EK2 would be EM2 minus EP2, which equals EM2 minus MGH2. And we have all those parameters as given, or we found them in the previous examples or previous branches of the problem. We have 0.613 joules minus 0.25 by 9.81 by 0.05. That would be 0.491 joules. What is the speed at the lowest point? It can be found from the kinetic energy. EK2 equals 1 over 2 mass by velocity 2 squared. Velocity 2 in this case would be the square root of 2 by EK2 over m. We know EK2 from here, and we know the mass as a given, so that would give you 1.98 meters per second. With that being said, you already successfully solved all the branches of this problem.